And what value do we already know? What's 3/5? That's my sine value. So everyone see where it says sine? Plug in 3/5. Plus 3/5 in for sine, still all squared. And now you guys got to use your algebra ability to help me get cosine all by itself. Can you get cosine all by itself? All right, go to your calculators. Can we do 3/5 squared first? 3/5 squared. 3/5 squared, should it be 9/25? Remember, we're trying to get cosine alpha all by itself. All right, algebra. Any algebra studs in the house? My next move to get cosine by itself. I squared it. I'm done there. What else should I do now to get cosine by itself? Subtract the 9/25 over, everyone. Subtract the 9/25. I don't have any sympathy for you because I'm asking you to subtract fractions. Everyone's got calculators that can handle this pretty easily. So now I'm left with cosine alpha all by itself squared equals 1 minus 9/25. 16/25? All right, so I got 16/25. Not there yet. I got one more step. How do I get that cosine by itself now? Algebra. How do I get the cosine by itself? Boom, here we go. Bassett, how do I get that cosine by itself? Suggestions?
Could you like square root it to get rid of the squared?
Absolutely. Yep. That's what you learned in algebra. That's what we're going to keep doing. To get rid of a squared, I got to take the square root. And a lot of you guys are getting 4/5. Everyone at home getting 4/5? Great, because we're not done though. Ooh. But wait. My calculator's giving me 4/5. I'm done. Do you remember back in your algebra days when you took the square root of a number, you get the positive and the negative version? Everyone remember that? Everyone at home remember that? You get the positive and the negative version? Here's why I said this at the beginning. What quadrant are we in? Second quadrant. Everyone, here we go. Now it's time to raise the bar. You're in the second quadrant, and we just found cosine. From Friday's class, if you missed it, I'm sorry. From Friday's class. If I'm in the second quadrant, is cosine positive or negative in the second quadrant? Positive or negative in the second quadrant? Had to be here. 5. Here we go. Ella, positive or negative? What's the S mean in the second quadrant?
I don't know.
Sine. Only sine is positive in the second quadrant. So what do you know about cosine? So that's why I'm just not going to put 4/5. I got to put negative 4/5, everybody, because cosine is negative in the second quadrant. Okay? You might not notice, but your camera went out, Donovan. It needs to be turned back on, refreshed. I don't know if you knew that or not. Everyone good there? Why it's negative 4/5? Everyone's good? Questions? Okay, one doesn't make you great. Let's keep going. One more of these. So now I'm back to theta. Now I'm in the first quadrant. So even if you want to put it in the back of your mind, what do you know about everything in the first quadrant? It's everything's positive. So at the end, you're just thinking, okay, my answer has to be positive at the end of this. Cosine, I'm just rewriting the theorem. Plus sine squared, I'm just rewriting everything. Equal to 1. Okay, it says cosine is 1/3. So everyone go ahead, 1/3 squared. We're going to get sine by itself now. Same thing, square it and then move it over. So 1/3 squared. 1/9. Again, how do I move the 1/9 over? Subtract it over. One minus 1/9. We're at 8/9. Look good? Everyone at home all right? 8/9. And then what was our final step? Get the squared out of there. Take the square root of both sides. Uh-oh, we're going to have a problem, but it's okay. I'll do it with you. I'll go to my calculator and do the same thing. So we're going to take the square root of 8/9. Uh-oh. Maybe we can turn it back into a fraction. Let's check. If I hit math, fraction. Oh boy. I can't turn it back into a fraction. And the directions. Look at the directions. Simplest radical form, right? Uh-oh. Okay, that's no big deal. Don't panic. How do I break this down? Everyone see how I put this over one big square root? You could have also done 2 square roots as well. Radical 8 and radical 9. Those two mean the same thing, everyone. Take a look. One big square root is the same as putting square roots over both of them. All right, you tell me now. What's the square root of 9 at the bottom? 3? Can we do anything with 8? Can we break down 8? At home, can we break down 8? I'm getting some yeses in here in class. Yeah, you can break it down into. Go ahead.
4.
Yep.
So yeah, and 2.
Okay.
And then you take the square root of 2 and leave it outside of the parentheses.
No, not you don't. You want to take the square root of 4, right, Caroline? That's what you're thinking.
Yeah.
And
yeah,
that.
that's what I meant. And then you have 2 radical 2.
2 radical 2 over 3. Good job. All right. There it is. And again, why is it going to stay positive? Why do I not put a negative in front? Because I'm in quadrant 1. Everything's positive in quadrant 1. Questions from you guys at all there? I am going to let you know if you care or not at this point, but I did put one of those on the quiz on Thursday, Friday. There's going to be one of those. Okay, where I give you sine, and then you have to find the other, and then maybe we'll be in a different quadrant. All right, everyone good there? Ready for today's stuff now? Anybody at home want to ask anything about the Pythagorean formula here? Okay, we are done working on the unit circle now. We're done working on the unit circle. All right, let's just get right into it. Let's rock right into example 1 right now. I don't even want to talk about this diagram, these circles up here. Okay, let's talk about number 1 right off the bat, because I'm going to get heavy and intense. Terminal side of an angle contains 3, 4. Remember what terminal side meant. First side is on the x-axis. The other side goes through 3, 4. So everyone graph 3, 4 on your graph right now, everybody. Graph 3, 4. And that's where the terminal side goes through. 1, 2, 3, 1, 2, 3, right here. I should probably put a different color. Okay, so that's what my angle looks like. That's what the angle looks like. And it wants me to find the sine and the cosine. All right, so here's my angle theta. That's the angle I just formed right there. I probably made that too big. There's my angle, theta. Got it? So it wants me, what is the sine of this? Okay, here, what's the sine? Usually, guys, stay with me. Usually, you pick off what coordinate for sine. What coordinate is usually represented by sine? Boom, here we go. Kian, what coordinate's usually represented by sine?
Y.
Y. So probably a lot of people are thinking, oh, it's got to be 4. I'm done. No. No. That's only if you're on the unit circle. And last week, and somebody just unmute your mic, or some of you guys in here can tell me in class. What's the top number we never go above for sine and cosine on the unit circle?
1.
Anybody at home?
1.
1. It can never be above 1. So that doesn't make sense that sine equals 4. I'm trying to show you guys we're not on the unit circle anymore. So how can I get this done? You're going to go back to your old buddy, Pocahontas' brother, SOHCAHTOA. We need SOHCAHTOA's help. I can find sine using SOHCAHTOA. Wait. Time out. Don't I need a right triangle to do SOHCAHTOA? Usually I can only use SOHCAHTOA in right triangles. Hey, look at your diagram. Can anybody make a right triangle up there? Everyone go from point 3, 4 and draw a line directly down, a vertical line. Everyone see the right triangle you just made from 3, 4. Yeah! Not only that, I guarantee most of you could tell me 2 side lengths on that triangle we just formed. Can you tell me what 2 side lengths are? What about the horizontal side down here, the bottom side? How long is that side? 3. And up, how many? Yeah, there we go. So I already know 2 side lengths. Whew. All right, let's talk about finding sine now. Sine of that angle. Everyone look at SOHCAHTOA. What is sine equal to as far as SOHCAHTOA goes? Sine at SOHCAHTOA, what's it equal to? Here we go. Sophia, what's sine equal to if I use SOHCAHTOA?
Four over.
Oh, no, you're going too far. Don't be a superstar yet. What sides do you need? Just taking after you two. What sides do we need? Opposite over hypotenuse. Now go ahead, be a superstar. What's the opposite side to theta?
4.
4 over, oh, we got an issue, don't we, Sophia? What's the problem?
We don't have the hypotenuse.
Yeah, but we have enough knowledge to find it in this class. What else have we done this unit and reviewed from geometry that you could find the third side from? Anybody?
Pythag.
Pythag. Yep, here we go. 3 squared off to the side plus 4 squared equals c squared. 4 squared. Anybody, by the way, anybody ever play that back in the elementary days? 4 square? No? Anybody at home? 4 square back in the day?
I did.
Yeah.
Yeah.
It got pretty intense. Did anybody have that friend, or maybe you were that kid, that just started all of a sudden making rules up as the game went along? He'd be playing, all of a sudden, cherry bomb, boom! And they were like, what's a cherry bomb? You're like looking around at all the other kids, like, who brought this kid to the game? I was that kid, by the way. Took it way too intense. Or you had the kid that put the spin on it, and you'd be going right, and all of a sudden the ball would go left, and you'd look like a fool. Yep. Back corner was always the best place to put it. 25 equals c squared. Good times, right? So the hypotenuse is 5. So the sine's going to be 4 over 5. 4 over 5 for my sine. We also needed to find cosine, right? Okay, if I have SOHCAHTOA up there, cosine is equal to? What sides can I use for cosine? Rest in peace. 14. Eliana, I don't think so. I hope not. I hope not, because that would have been awful. Eliana, what do you have for the sides for cosine?
It's adjacent and hypotenuse.
Okay, what's the adjacent side here?
It's 3.
Hypotenuse?
5.
Good job. So everyone see how we found sine and cosine, even though we're not on the unit circle. We just made a right triangle and did SOHCAHTOA. Anything there? Because there is there's a third piece left to this problem. Anything? Okay, last piece. Find sine, find cosine, and find theta. How many degrees is in that angle right there that we just made? How many degrees? What quadrant is it in? 1, so you at least know my answer's got to be between 0 and 90. All right, how can I find that angle? And I don't know if anybody remembers our review from last week. Go to your calculator. Remember the buttons we need to find an angle? Remember the inverse of sine, inverse of cosine, inverse of tangent? That's how we're going to do it. Everyone remember those buttons at home? Inverse, sine, cosine, tangent? All right, well, you get your choice now. You guys in here pick for the class. Do you want to do inverse sine or inverse cosine? Sine, okay. So here's how they picked to do inverse sine. So we're going to do inverse sine to find the angle. And what fraction are we plugging in if we're using sine? 4/5. If you guys chose to use cosine, no big deal. You would use 3/5. Make sure your calculator's in degree mode. Degree mode. It won't come out to be correct if it's not in degree mode. Especially you guys that are using the Chromebooks. I don't know why, but every time you shut down the Chromebook, it automatically goes back to radian. So if you're using the Chromebook. And what are you getting for angle theta? 53 degrees. That works because it's in quadrant 1. So now get in the habit of going to be making a right triangle to find sine and cosine. All right, anything here? Because now, after we've done one, usually I'll pick up the pace a little bit now. Any questions on those right there? Because now what's going to happen is you're going to go to a different quadrant now. Instead of being in quadrant 1, we'll go somewhere different. Guys at home, any issues? Okay, let's go. Let's pick it up now a little bit. Same question. Now the terminal side goes through 6, -5. So here's my x-axis. Make sure you graph 6, -5 now. 1, 2, 3, 4, 5, 6, 1. Right here. So there's the, again, we're in the 4th quadrant, right? So remember, this is theta right here, guys. This is theta. Right? In the 4th quadrant, that's theta. Can you guys make a right triangle out of this? Okay, now, hey, take a look at my diagram. Take a look at your screen. Some people are going to make this right triangle right here. And some of you may elect to do this right triangle. You always make it with the x-axis. Okay? Here's why. I always want my reference angle to be the angle I go from. So make sure you always make that right triangle with the x-axis, guys. X-axis, because you always want to go from your reference angle. Okay, you always want to go from that reference angle. All right, can you put 6 and 5 on there somewhere? Can we put 6 and 5 on my right triangle? 6 going across. And this is a length of 5. Okay, this is tricky, guys. We're in a different quadrant. Anybody, you see that 5 I put down there? What do you know about all the y values where I put that 5? Yeah, so that 5 better be negative. Okay, make sure that 5's negative, because all the y values are negative down there. All right, sine, cosine, here we go. I'm not even going to ask because we don't have enough information. You guys know if to find sine and cosine, you need your hypotenuse. So off to the side, Pythag to find the hypotenuse. 6 squared plus, make sure you put -5 squared in parentheses in your calculator. C squared. (36 plus 25 equals c squared). 61. So you guys are getting what? The square root of 61? And don't give me decimals, just leave it. Square root of 61, that's fine. Just leave it as the square root of 61. All right, here we go. Back to you guys. Sine. And remember, I just can't pick the y coordinate off because it's bigger than 1. So I need to do SOHCAHTOA. So SOHCAHTOA tells me to do what for sine? What am I doing for sine here? Mason, what do I do for sine?
You're going to use -5 over the 61.
Yep. Opposite -5 over hypotenuse square root of 61. And we're going to play this game where I start staring at you awkwardly until somebody tells me why I'm not going to move on. Good. Ella says, have some self-respect, period 5. You cannot have a radical in the denominator. Correct. So we cannot leave it there. Anybody remember how we adjust it? We've done it already this year. Multiply by radical 61 over radical 61. Yep, to get it out of there. Self-respect from now on. Don't be an embarrassment to the math community or to your family. You're better than that. So up top, I get -5 radical 61 over 61. Radical times itself is the number underneath. Good, done. I know that doesn't look the prettiest, but it's going to work for us. Okay, what about cosine? What's cosine going to look like? Kian, what's cosine going to look like?
It's adjacent over hypotenuse.
Yep. What's the adjacent side?
-5.
I thought that.
Oh wait, no, it's 6. It's 6.
Okay, good. 6 over what?
Radical 61.
The hypotenuse, and you have self-respect, right, Kian?
Yep.
All right, you're not going to leave it like that. How do I undo? How do I get rid of the radical again?
Multiply by this same thing on the denominator, so radical 61.
Yep.
You get rid of it, so it's 6 radical 61 over 61.
Good man. Good job.
Yep.
Everyone all right? And then there is that third part, which is what? Find the value of theta. All right, let's talk first. What quadrant are we in? Everybody, what quadrant? 4. So you know your answer should be between 270 and 360. All right, hold on before I grab the calculator. I know in the last problem, I gave you guys a choice. You could do inverse sine or inverse cosine. Here, I'm not going to give you a choice. I would always prefer you do the inverse of the positive fraction that you have. Let me say that again. I would prefer, and there's a reason behind it I don't want to get into. All right? I would prefer you do the inverse of the positive fraction you have. So in this case, I would like to see you do inverse cosine. And there's a great reason behind it. Maybe later on in the unit we can talk about it. But right now, just trust me, use the positive fraction when you find the inverse. So I'm going to do inverse cosine, 6 radical 61 over 61. So everyone go ahead, go to their calcs. And then everyone's going to see an interesting answer there. To the nearest degree, what's your calculator giving you? About 40? That doesn't make any sense, though. 40? You said it had to be, but we're in the 4th quadrant. Do you know what your calculator is actually giving you? Because this is what it's programmed to give you. It's not giving you the actual angle in the 4th quadrant. It's giving you the... What do we call that angle less than 90?
The reference angle?
It's giving you the reference angle, yes. Your calculator is only programmed to give you reference angles. So the reference angle's 40. You have enough knowledge. I know you do. Can you find the angle in the 4th quadrant knowing that's 40? You got more than enough knowledge to do it. Okay, calculator gave me the reference angle was 40. How can you find the angle in the 4th quadrant? Do what? 360 minus 40. 320 degrees. So remember, your calculator only gives you reference angles. You have to take the reference angle and go from there. Okay? Whew, everyone all right? So that was, we did one in the first, we did one in the fourth. Relax. Everyone good? Bunch of drama queens in here, including you, Isaiah. Got it? Any other questions? Anybody at home before we get into one more before we call it a day? And again, I don't care anymore that I'm going right up to the bell because you guys get all tomorrow to practice. All right, here we go with 3. 3 is a little different because I didn't give you the point it went through. But I do give you the quadrant we're in. What quadrant are we in? 3, yep. I'm in quadrant 3. Do you think you could set up a triangle in quadrant 3? A correct right triangle in quadrant 3. Ooh, quadrant 3. So I know the terminal side is going to go in quadrant 3, just something like this right here. Do we know how to make, remember, what do we always make the right triangle with, the y or the x? With the x. So that's what my right triangle looks like there. You guys want a little trick on how to write the right triangles correctly? You want a little trick? Think of wearing a bow tie. Think of wearing a bow tie. What are you, bow tie? Do you see the right triangles in every quadrant now? That's what they should look like. Okay, no matter what quadrant you're working in, that's what the right triangles should look like. So if you want to remember the bow tie, that's how I remember how to draw my triangles. Okay? So just remember the old bow tie. It'll show you how to draw the triangle in each quadrant. Okay. Wait. Hey, guys. Last 2 problems, you were able to label 2 of the sides so we could do Pythag. Can we label 2 of the sides? You don't know it, but you can. Other than quadrant 3, what other piece of information did they give me? I know what the cosine is. I know what the cosine is. -8 over 17. Everyone thinks SOHCAHTOA. What's cosine equal to as far as SOHCAHTOA? Come on. Donovan, here we go. What's cosine equal to as far as SOHCAHTOA?
Isn't it, it's the comp part, right?
It is the comp part, yes.
Adjacent hypotenuse.
Adjacent over hypotenuse. Everyone take a look. What's in the adjacent spot? What number? -8. So go to adjacent. -8. What's in the hypotenuse part? What number? 17. Hypotenuse is never negative. Hypotenuse, never negative. Everyone see how I got those 2 sides? How do you find the third side? Pythag. Be careful though, be careful. What's this Pythag going to look like? -8 squared plus, be careful, it's not 17. B squared. 17 is the hypotenuse, that's C. 17 squared. Okay, you're solving for a leg here, so that's B squared. So go ahead, solve for that B. What was 17 squared? 343? Or 289, that too. B squared should be what, 225? Take the square root, it's got to be 15. Okay, so that side's 15. Ooh, take a look at it though. Here's where little things like this. Look at where we just put the 15. Anybody want to tell me anything about that 15? Look where it is on the graph. It's got to be negative, right? Because that's where it's going down on the y-axis, so it's got to be negative. All right, let's finish this bad boy. Got plenty of time to finish this. Maybe not. What am I looking at here? Yeah, we're all right. And find the sine of the angle. Opposite over hypotenuse. Okay, what's opposite my reference angle? Always go from the reference angle. What's opposite your reference angle? Negative 15 over 17. Yep. And then I don't have enough time for this, so I will show you guys first thing tomorrow before I let you go how to find the angle of the third. Okay, no matter if you're in class tomorrow or you're home, it's time to practice. Also, Donovan, Miss Burkhart wanted me to relay a message. She's looking for you to reach out. She's reached out to you a couple times and you haven't already, so she said, ask me to tell you. Hunter, just stay on afterwards for a second. Thanks, guys. Have a good one. Good job today.